Okay, so we have talked about our states of matter, and we have talked specifically about a couple of states, especially gases. So now we're going to talk about changes of state. So a change of state is when a substance is changing from one physical form to another. So going from liquid to solid, solid to liquid, liquid to gas, those are the kind of changes we're talking about. So remember when we talked about physical and chemical changes that a chemical change is one where the identity of the substance changes, but a physical change is where the substance does not change identity, just appearance. So remember that a change of state is a physical change. It's not changing what the substance is, it's just changing the way it looks. It's changing its physical form. So, but even though it's not changing the identity of the substance, there still is energy that has to be added or removed to for these changes to happen. So we're going to talk about some terms called endothermic and exothermic for the first time while we're going through this, and to talk about if the energy is being added or if it's going to be removed. So our first state change is from solid to liquid, and that is melting. So we go from we go from solid to liquid. This is definitely one that you guys, I would hope, are familiar with. Ice melting into liquid water. That just goes. It's simply going from a solid to a liquid. So in this case, you have to add energy to that until the temperature increases. So if you think about it, you have to add heat for ice to melt. So you're adding energy into that for ice to melt. So in melting's case, you're adding energy, um, and when you add that energy, it makes the energy inside of that change increase. But if there's a decrease in the surrounding temperature, sorry, I'm looking for the right words, um, it's taking the energy from the surroundings, so it's going to decrease. So that means that that's an endothermic change. So when we add energy, it's taking that energy in. So that's why it's called endothermic. And then also another thing about that is the temperature at which the substance changes from solid to liquid. That's called the melting point. So the temperature that most substances have a specific temperature for that. For water, if you're going from a solid to a liquid, that is going to be around 0 degrees Celsius. So that would, once you get higher than 0 degrees Celsius, that's when you hit that melting point. Solid, just like the melting point, there is a freezing point, so the point in which liquid changes into solid. Again, for ice or for water, it's going to be about 0 degrees Celsius because that's where water freezes. Once you get below that, that's where it's especially going to start freezing. And this is an exothermic change because now we are energy is being put off. They're taking energy out. It's getting colder inside that reaction, so it's going to be an exothermic change. Alright, so our next change of state is evaporation. And this is the change of a substance from a liquid to a gas. So again, I think most of you guys have probably heard of evaporation. Puddles outside, they don't just they don't dis well they do disappear into thin air, but it's because they're changing state into a gas and go back into the atmosphere. So a term that is associated with evaporation that you may not think about is boiling. So boiling, the definition, is a change of a liquid to a vapor. Now, a vapor is just a specific form of a gas. So boiling is just a form of evaporation. So when you boil pot of water, you are just causing that water to evaporate into a vapor. But something that's pretty neat if you think about, we've been talking about some of our gas behaviors, how volume and temperature and pressure all interact together. If you live in a place that has high altitude, such as Denver, it is a mile up, if not more, the water is actually going to boil at a lower temperature because it is a higher altitude. So because it's higher in the mountains, the air is thinner. So there's less particles, which means there's going to be less air pressure. So because there's less pressure, it does not take as much energy to get those particles moving because there's less particles. So it takes less of a temperature to get the state of change to happen. So it doesn't take as much for you to go from that liquid to that gas. So if you ever move to Denver or go to Denver, there are definitely different directions on how to bake and how to boil your water, because it does make a difference being in a whole different pressure. My cousins live in Denver, and she said she had to basically completely relearn how to do her baking, because it makes a really big difference being somewhere where there's different pressure. It really messes with the gas and the temperature relationships. Right, condensation is a change from gas to liquid. So if you've ever seen the water beads on your cup, if you have a cold cup that's on outside when it's hot, that's because of condensation. And this is also an exothermic change. So you're putting energy into that change for it to happen. You have to have heat for that to happen. Um, and then this point where we're taking a gas to a liquid is called the condensation point, just like melting and freezing point. The change of state in which you take a solid that goes directly to gas is called sublimation. So this is one you may not have heard of. There's not a lot of common examples, but definitely the most common is dry ice. So if you've ever seen dry ice, when you take it out to room temperature, it just creates this fog. That's because that solid is going straight into a gas. It's skipping the liquid phase. So this is an endothermic change. So there's energy taken away when that happens, when it's going straight from there to there. So uh, again, not super common, but dry ice is definitely something that most people have probably seen or at least heard of. And then also with thermal energy has to do with our changes of state. Um, One thing to keep in mind is that thermal energy is always going to move from a warmer substance to a colder substance. So if you have particles that are moving super fast, and it's touching another substance that the particles are moving quite as fast, that thermal energy is going to transfer over because they want to balance out. They want everything to be moving at the same speed. So that's why if you touch a hot pan, that heat transfers to your hand. Instead of the lack of heat that you have, the less energy going to the pan itself, you're getting that thermal energy on your hand because it's trying to pass from somewhere that has more to somewhere that has less, and that's why we can feel things like that. So just keep that in mind about thermal energy.